Properties of kites and trapezoids. Our objective is to use properties of kites and trapezoids to solve problems. Why learn this? The design of a simple kite flown at the beach shares the properties of the geometric figure called a kite. Some vocabulary to know. A kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. The base of a trapezoid is each of the parallel sides, as you can see below. The legs of a trapezoid are the non-parallel sides. And base angles of a trapezoid are the 2 consecutive angles whose common side is a base. So this is 1 pair of base angles. This is a different pair of base angles. An isosceles trapezoid is when the legs of a trapezoid are congruent. And the midsegment of a trapezoid is the segment whose endpoints are the midpoints of the legs. Let's look at a couple properties of kites. If a quadrilateral is a kite, then its diagonals are perpendicular. So if it's a kite, then the 2 diagonals are going to be perpendicular, meaning they make a 90-degree angle here. If a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Only 1 pair of opposite angles will be congruent. For example, A and C are not congruent. Only angle B and D are. Using properties of kites. In kite EFGH, the measure of angle FEJ is 25 degrees. The measure of angle FGH is 57 degrees. Take a moment, use the given information here to try to figure out what the measure of angle GFJ is, the measure of angle JFE is, and what the measure of angle GHE is. Alright, so the first one is the measure of angle GFJ. GFJ. That's this angle right here. And, well, we know that this one has to be 90, because we are in fact dealing with a kite. So, if you have a right triangle, you know that the other 2 angles must add up to 90 degrees. So, you can simply subtract 90 minus 57, and that gives you 33 degrees. Let's change color here. We're going to go green. Alright, so let's look at the measure of angle JFE. The measure of angle JFE is this one here. We have JFE. We can use the same principle. We know that this angle must be 90, for the diagonals are perpendicular, so we can simply take 90, subtract 25, and get our third angle in this triangle. In this case, 65 degrees. And last but not least, we have the measure of angle GHE. GHE is this whole angle right here. So we know that our opposite angles here, because it's a kite, are going to be congruent because we have 1 pair of opposite angles being congruent. So we can take our 2 pieces, our measure of angle GFJ and our measure of angle JFE, and add them together. So 33 plus our 65 is going to in fact give us the measure of angle GHE. And in that case, it's 98 degrees. Let's look at a few more theorems. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So our base angles are congruent. Angle A and angle D are congruent, and angle B and angle C are congruent. Be careful, this only happens if it's in a isosceles trapezoid. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. This is basically the reverse of the one we just read. So, if you have base angles that are congruent, then you know the triangle or the trapezoid is isosceles. And the last one. A trapezoid is isosceles if and only if its diagonals are congruent. So, our diagonal, BD, is congruent to AC, so therefore it's isosceles. And since it's an if and only if statement, it's a biconditional, which means you can go either way with this. Let's try applying some of these. Using the properties of isosceles triangles. Well, if we look at this first one together, we have angle W is 117 degrees, and it's asking for the measure of angle Y. Well, we know that the measure of angle Z must also be 117 degrees. And we have two parallel lines. We can think of this YZ as a transversal. So we know that the sum of Y and Z must be 180 degrees. So we can simply subtract 180 minus 117, and that will give us 63 degrees for the measure of angle Y. Take a moment and pause the video and try to figure out what PS is in this next trapezoid. Now that you've had a moment to try and find PS, let's see if we can do it together. RT is 24.1 and QP is 9.6. Well, we know that the diagonals must be congruent, so we can simply take 24.1 and subtract 9.6, which gives us 14.5. Let's get a little bit more challenging here. Find the value of Y so that EFGH is isosceles. Well, if it's isosceles, you know that the base angles must be congruent. So, therefore, set both of these equal to each other. We have 2y squared minus 25 must equal y squared plus 24. We want to get our variables to the same side of the equation first. So we're going to subtract y squared from both sides, leaving us with only 1y squared left, minus 25 equals 24. We can add 25 to both sides. And now we have y squared left on the left-hand side, and we have 49. Y squared is not by itself. The opposite of squaring something is taking the square root of it. So y equals the square root of 49, which is 7. Take a moment and pause the video and try to figure out B. Before we go on to B, I'd like to backtrack to A. When you take the square root of 49, it's not just positive 7, but it could also be negative 7. If you think back to algebra, if you do 7 squared, that's 49, and then if you do negative 7 squared, that is also 49. So it's a good idea to have both answers here. Alright, back to B. We have JL, so JL is 5x plus 3, and KM is 9z minus 12. Find the value of z so that JKLM is isosceles. Well, since diagonals must be congruent, we would simply set 5x plus 3 equal to 9z minus 12. We want to get our variables to the same side of the equation. And we have 3 left on the left-hand side, and we're left with 4z minus 12. So we're going to add 12 to both sides as we want to undo addition and subtraction first. So we now have 15 equals 4z. And when we divide both sides by 4, we end up with z equals 3.75. Let's look at another theorem, the trapezoid midsegment theorem. The trapezoid midsegment theorem states that the midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of its bases. So all three of these are going to be parallel. We already know if it's a trapezoid, our two bases are parallel, and our midsegment is now parallel. So it's basically like taking the average. If you add up your length of BC and your length of AD, add them up and divide them by 2, that's going to give you your XY. Let's try an example. Find the length of ST. MN is equal to 1/2 ST plus RU. Well, let's substitute what we know. MN is 31. We rewrite our half here. ST is our unknown. We don't know what that is. And RU is 38. Well, we want to get rid of this fraction out here, so we're going to multiply both sides of the equation by 2, leaving us with 62 equals x plus 38. To get x by itself, we're going to simply subtract 38 from both sides. And that gives us x equaling 24. And since we used x to represent our ST, ST is in fact 24. This concludes our video on properties of kites and trapezoids.